Hi, my name is Rachel, and I'm going to teach you about Chapter 13. So Chapter 13 is all about the molecular model of matter, and it's our second model in our list of models of matter that you need to know. So the first one was the continuous model of matter. So the continuous model of matter says that if you cut a piece of butter in half, for example, you could do that for infinity number of times, and you'd still just get a smaller piece of butter. So there's no fundamental particles or anything like that. Matter is continuous. One day, a man named Robert Brown, he was looking at a piece of dust under a microscope, I don't know why, and he found that it was jiggling back and forth. And so he said, that's really weird. There's no reason this dust particle should be jiggling back and forth. And so then he came up with the idea that maybe air isn't just like this continuous thing of air. Maybe it's made up of little particles that we can't see. And they are colliding with this dust particle, and that's what's making it jiggle back and forth, okay? So what should have happened if the continuous model was true was that the dust particle would have just been at rest and still. But because it was moving, he knew that there must be particles colliding with it. And now we've got the molecular model of matter, which has 4 things that you need to know about it. So first, that everything's made up of little molecules or atoms that aren't divisible. So there's no like nucleus or electrons or protons in this model. It's just molecules are the smallest unit. Then we've got different matters made up of different types of molecules. So I'm made up of different types of molecules than this piece of chalk. And the third one is that they're always in motion. In solids, they're vibrating, and in gases, they're free to move around more. Then we've got the last one, which is that they obey fundamental laws. So gravity and conservation laws and Newton's laws of motion, they obey all of those laws, even though they're really tiny. Okay? So now that's the molecular model, and you just need to know some things that it explains. So it explains temperature, for example. We know that temperature is just the average kinetic energy of all of the molecules in a substance. So average kinetic energy, if you'll remember from Unit 1, is 1/2 times the mass times the velocity squared. So temperature is just the average kinetic energy of all of the molecules in a substance. And we know from Unit 1 that kinetic energy is equal to 1/2 times mass times the velocity squared. So that is just, so temperature just depends on the mass of a molecule and the velocity of a molecule, okay? This knowledge can help us understand this graph. So at 25 degrees Celsius, if we measure the speed of these different elements, we see that most of the argon atoms are going to be moving a lot slower than most of the helium atoms, even though they're at the same temperature. So why would argon molecules be moving slower than helium at the same temperature? And that's because we know that temperature is dependent on kinetic energy, which has mass in the equation. So helium has a smaller mass than argon, so in order to have the same kinetic energy, it has to be moving faster. And so at the same temperature, something with a smaller mass will be moving faster than something with a larger mass, okay? So that explains temperature. We can also understand something like heat flow because we know that hot molecules are moving really fast and cold molecules are moving slowly. So when a hot molecule collides with a slow molecule, it's going to speed that slow molecule up, making it hot, and slow the fast one down, making it cold. So heat flows from hot to cold because it's just fast stuff colliding with slow stuff. It also explains pressure. So pressure is just molecular collisions, okay? So if you blow up a balloon, the balloon gets it expands because of the pressure inside it, and that's just all those air molecules colliding with the inside of the rubber balloon. And if we heat a balloon up, we know that our average kinetic energy increases, and so those molecules are going to hit the inside of the balloon harder and increase the pressure in the balloon. So the molecular model of matter can also explain density. So solids are generally moving slower, so because they're moving slower, they don't take up as much room and you can fit more in a certain area, as opposed to gases, which are moving a lot faster, and so you can't fit as many of them in a specific area. So gases will be less dense because they're moving more. So heat flow, density, pressure, temperature. Those are all things that the molecular model of matter explains. And if we look at temperature, this is one graph that you need to know. This is a phase change diagram. As we look down here, this is a solid material. So let's say we have an ice cube, for example, and we start at like negative 100 degrees Celsius. Okay? So as we heat that that ice cube up, the temperature will increase in the ice cube and until it gets to 0 degrees Celsius, which is its melting point. And then once it gets here, we notice that the temperature stops changing while it's melting from a solid to a liquid, but our total energy is increasing. And that's because even though the molecules aren't moving any faster, they're getting further apart. So that's increasing their electrical potential energy. So we know that liquids are less dense, right? So their molecules are further apart, and that requires energy to move them further apart. And so that's where this energy is going right here. It's going into internal energy. And then once it's all melted, so it's all a liquid, then they'll start becoming faster again. So our temperature will go up as they speed up. And then once they reach a certain temperature, for the case of water, it'd be 100 degrees Celsius, they'll start moving further apart again to become a gas. And that will increase their electrical potential energy as they evaporate. And so that's the molecular model of matter and everything that you need to know about Chapter 13.